So today's webinar is going to be pretty fun and informal, but also we hope informal. So I'm going to go ahead and introduce our distinguished presenters. First up, we have Jim Vandergiesen. He is the CEO at Pro Refrigeration, Inc., which is a manufacturer of high-quality refrigeration equipment for niche cooling applications. Jim was just 21 years old when he and his father opened the doors of the company that was focused on instant cooling of milk on dairy farms. So you hear a little bit more about this during the case study. But it was this concept that drove the development of the Pro Chiller that was introduced and tested into the emerging craft beer industry as well. And over the next 30 years, Pro and Jim, they worked hard to remain relevant to both dairy and brewing industries. And they invested heavily in the development, not just of the equipment they produce, but also the services, tools, and the team itself to collectively support their customers. Next up, we'll have Derek Settlemeyer, who's an AWS certified senior software architect here at CEI. Derek is very well versed in connecting and leveraging the tools in the AWS platform to drive client value and predictive insights, especially around IoT. And last but certainly not least, we have Brett Cocking, who is our VP of the AWS Business Group here at CEI. And prior to joining CEI, Brett was at AWS itself, where he was responsible for building and leading AWS's first ever global IoT specialized sales group. So that's quite the panel, and they're going to have a lot of fun today. So quick overview of what we're going to cover. Brett will give you a quick high-level overview of the AWS IoT and some use cases. And then we'll jump into the case study with Jim, and he'll share about Pro Refrigeration, some of the challenges they were facing. And then Derek will give us an overview of the solution, and we'll turn it back over to Jim to talk about the benefits that they're seeing and what's next for Pro Refrigeration. And then we'll jump into the Q&A, and Brett will wrap up with us on how you can get started and how we can help you.
Well, let me start. Norma did a great job kind of introducing me and what Pro does. I'll add a little bit to the elevator pitch. Pro Refrigeration, we are a technology company that builds chiller systems, but chiller systems is our focus, and we do the technology for that purpose. That's also we try to stay true to that. But if you had to kind of put us in a box, really, chilled fluid applications where you're operating from negative 45F, which is negative 43C, to plus 45F. That's our wheelhouse. That's our standard operating range, and those are kind of the applications and the emerging cooling applications that we target. And our background is cooling milk and cooling beer and craft beverage primarily. And our emerging markets that have come out in the last few years is the extraction industry and literally hundreds of others. We love to find a market. For example, the extraction market has got us excited because there's so many operations that are obviously there's a lot of people figuring it out right now, and really getting that path to a scalable solution as these groups ramp up it's been great to partner with some nice groups, and we're excited about that angle. And we have our headquarters located here just outside of Seattle in Auburn, Washington. That's where we do all of our custom industrial product development. And kind of all of our housekeeping comes out of that facility. And then in North Carolina is our standard production facility, where we do, produce all the standard products and have what I call our world-class manufacturing facility. And yeah, that's kind of who we are. If you want to go to the,
yeah, Jim, I just want to weigh in on something. And I, right after you created ProLed, I think we went to the Craft Brewing Conference in Nashville. And I'll tell you, I mean, I think just what you did early on disrupted that industry, because the amount of attention you were getting at that event was second to none. I think they even had international media reaching out to do interviews with you. So it was really fun to see that. And Jim, I think obviously, I think you've done a fantastic job. I think you've really leveraged IoT to help disrupt the chiller industry, and it certainly is well recognized in your segment.
Thank you. Yeah, and all of the industries, and a lot of people would look past the dairy industry as the technology driver that it is, but and obviously craft beer has so many forward-thinking people that are pushing the edge and driving us, and that's great. But also we're getting just as much pressure, if not more, from the dairy side. And here it kind of talks about, we'll jump into now what instant milk cooling is, and it comes down to getting that milk from 101 degrees, which is the temperature it leaves the cow, down below what the USDA calls their bacteria danger zone, which is below 40 degrees. And we do that as quickly as we can. It's called instant cooling. We use a two-stage heat exchanger using well water and then a cooling fluid, which is propylene glycol, to cool that instantly to 36 degrees. And we'll either load it into a storage tank on the farm or sometimes directly onto a tanker truck. But that's kind of our strategy: get it below that danger zone, and then just make sure, using Pro Elliott, using our tools, using our equipment, that really that milk never, once it is cooled below that operating temperature of 40 degrees, it never gets above it. And that's our focus. And Derek, if you want to come in, we can kind of get into the nuts and bolts of the Greengrass and kind of the cold chain verification process.
Yeah, thanks, Jim. Yeah, I have to say, starting this effort really gave me an education on milk cooling, something that I didn't know about before. So yes, so for some of the technical challenges for cold chain verification, Brett and Jim touched on these, at a high level, but I wanted to kind of talk more about the technology behind it. There's three main, the technical challenges we have to worry about here, and that's, the first one's connectivity. So when you have these gateways and these sensors out in the field, it's important to consider the type of environments that your IoT environments will be running in. You have to realize that connection to the internet and connection to AWS may be intermittent, but we still have to capture the data points so that we can verify that these temperatures they remain below those safe thresholds.
Exactly.
So, yep. So one of the things to make sure that we durably capture that data, it's really important to use store and forward technology at the edge. With store and forward, data is retained at the edge and delivered to the cloud once there is an active connection. So there is that buffer that's sitting on that device collecting data until that online connectivity is restored, and then they can push it up to the cloud. And then when deploying these devices to some of these spaces, there could be cases of poor connectivity, particularly with Wi-Fi. You may have, when you're doing an initial setup, you may have a good Wi-Fi connection, but you may find that maybe the access point's moved, or you're really at the edge of that Wi-Fi range. So as it moves forward, you lose that connectivity and you lose that reliability. So they really perform poorly in long term. So, excuse me, for most situations, cellular connectivity is preferred. So the device has a more stable connection. And also, if you're going into an environment where you could have potential issues with deploying these devices on a local network or corporate network, it's more advantageous to have that cellular connectivity, because you're not having this device that's sitting on a corporate network doing various things that may cause security concerns. So the cellular connectivity can help in those situations. And then the next is streaming and filtering. So like Brett mentioned, as data is being captured, we may not need to send all that data back to the cloud. So we want to be able to analyze that data locally to see, is this an anomaly? Is this something that we want to keep a record of, or is it just a normal occurrence that we can discard? So this is where the streaming and filtering kind of come in, and we can do kind of streaming analytics at the edge, where we can build up time windows to do analysis of data. We can aggregate and filter the data that can go to the cloud, but then also we can aggregate and filter in order to perform some sort of action at the edge. Maybe it's increasing or decreasing temperature. Maybe it's opening a valve, or opening up an actuator, or some action at the edge that can be done based upon some of the streaming and filtering data. And then when we look at analytics at the edge, we're really looking at analytics to perform some action. So, in the case of the milk use case, it's really monitoring temperature trends. And we want to be able to do this without requiring cloud connectivity. So we could have a simple function or a Lambda function sitting at the edge that is checking the temperature that's coming in from the sensors. And if that temperature exceeds some temperature threshold, then we perform some sort of action. And maybe it's just a simple email if there's connectivity, or an SMS message if there's also if there's connectivity. But also it could mean just throwing on a warning light at the edge. Maybe there's some light device that we can flag on when the temperature has exceeded some threshold. But then we can get into some more complex actions at the edge, including changing some of the equipment settings, maybe decreasing temperature at some point so that when milk hits the primary vat, that it's cooled appropriately. And then we can get into some of the complex analytic scenarios where you have, based on the data that you've collected in the cloud, you can start training and testing machine learning models that do some predictive analytics and inference. So you could take those machine learning models that you trained in the cloud, and you can deploy them to the edge, and you can feed that incoming data to that machine learning model to do more predictions based upon the real-time values.
Hey, Derek, and this is Brett. One thing I just want to throw in there, and I think we might get into this a little bit later, but even doing the predictions, say, hey, the milk is at 36 degrees currently, but we know that this milk's destination is an hour drive away. We know that the weather's going to get hotter. It's going to get to 80, 85 degrees en route, predicting and saying, hey, guys, to stay under that 40 degrees, you need to deliver that milk within this time frame. Don't stop for lunch. Keep going, because you've got X number of hours before that milk is going to hit in that danger zone. So that's another really
Brett, your microphone cut out for us.
Yeah, I think my Bose headset died. I apologize. Can you guys hear me okay?
You can.
Okay. Let me interrupt you, Derek, but yeah, I just wanted to point that out. I think that's a really interesting use case. It's almost what I think Jim and I referred to that as almost a milk flight plan. What's the temperature of the milk now? Where's it going? And is it gonna be at the right temperature and it reaches its final destination? And if not, if there's an area of concern, how do you get that milk there faster or chill it more before it goes on its initial journey?
And we can even, to interject, that's even part of the program that we're working on now. I mentioned we're instant cooling the milk in a 2-stage heat exchanger. There's oftentimes we can sense early on that we're not being effective in either the first or the second stage, and that does give us the capability to adjust. We can do more cooling in stage 1 or stage 2, by making adjustments, and it falls right in line with this.
Yep.
Perfect.
So really the technology that kind of drives all this, besides just the core AWS IoT services running in the cloud, is AWS Greengrass. So really Greengrass is just a piece of software that runs on a gateway device at the edge, or in this case, it'll be on a dairy farm. And this software allows various things to happen. So it provides that local compute. It provides messaging capabilities between some of the internal components, so that you can act on various conditions at the edge, and it can also sync data and run ML inference capabilities on those devices. So if you're familiar with AWS, Greengrass allows these devices to run Lambda functions. So when you can deploy your Lambda functions in AWS and deploy those out to your Greengrass devices that can act and ingest sensor data. They can act on that data. They can send notifications. They can interact with the sensors or other IoT things that are at the edge. And also these devices with Greengrass can run, if you have Docker images, they can run your code within Docker containers. And then as I mentioned, they can execute predictions based on machine learning models and keep the data in sync with that store and forward technology. And really, what it's doing, extending AWS to these devices, so that you're getting the same type of development experience as you would when using the cloud, the cloud services. So the cloud IoT core and the MQTT brokers that are in the cloud, you'll get the same thing within Greengrass.
Derek, all I want to say is I think, a couple of years ago it was really difficult to find an off-the-shelf gateway that was running Greengrass. Now they're fairly ubiquitous, meaning, most of the major gateway manufacturers, whether it's Advantech or Laird, manufacture or build a Greengrass-enabled gateway from the factory. And literally it's a matter of picking the right one and configuring and say, hey, I need one that's got connectivity, that's Wi-Fi, that's LTE, and then I need X number of inputs. But one of the things that's really changed in the industry is the fact that these gateways are readily available from a range of manufacturers, which wasn't the case 2 or 3 years ago. And I think that is a differentiator. It just helps to expedite these types of projects, be able to pick the flavor of the gateway you want, have it drop shipped in, it's already pre-configured for Greengrass and ready to connect.
Yeah, that's true. A lot of them, you can provision them automatically through a mobile app into your AWS environment to make it real simple to get your configuration and your code out to the edge for your specific use case. So if we look here at a proposed architecture, we have 2 areas here. We have the gateway device that's running Greengrass, and then you have AWS and your AWS account. So if we work from left to right, we can see that that we have sensors that are feeding into this gateway device. They could be using Modbus, which is a pretty common messaging for sensors. And there's already a Modbus connector within Greengrass that can be used, and there's you can use a Lambda function to read data from that connector. You can feed it in through message filtering, maybe check for anomalies, and then push that data to an MQTT broker that's running in that Greengrass core. And then from there, MQTT, it's that broker's providing some publish subscribe mechanisms, so you could have other things within that core that's subscribing to these messages. So you may have a function there that's listening for temperature values, and if that temperature value exceeds a certain threshold, then send a message through SNS, or send an SMS message through another service. But then, for more advanced scenarios, you can use a machine learning model and run ML inference at the edge, and use that real-time data that's flowing into that broker, and performing some sort of inference on it based upon the machine learning model that's been deployed to it from the cloud side of AWS. And then, as any data that you want to capture long-term in the cloud, the MQTT broker will communicate through the internet out to AWS IoT Core, where that data, you can set up different roles to do various to perform various actions on that data. One of them could be just storing the data long-term in S3 in sort of a data lake. And then, using that data that's in the data lake, you can use SageMaker to help train and test those machine learning models that will eventually get deployed through Greengrass down to the devices. And then with IoT Core, you can have another role that feeds it into a dashboard application or mobile application, or perform any actions cloud side that you really want to do with that data that's coming in from the devices.
Interrupt real quick, since it seems like we got a question that seems to pertain pretty specifically to this discussion. So we have a question: how many devices can a gateway support? So if you can answer that, Derek.
How many sensor devices can a gateway support, or how many Greengrass cores can a device support? So if we're looking at
chillers, or how many chillers?
Sensors.
Yeah, this is Brett. Yeah, a lot of it depends on how many communication ports and which communication portions you're using. If you're using something like a LoRa type environment or Bluetooth, you know, it all depends. I don't think there is a quantitative number for the number of sensors that can interact with a Greengrass gateway. It would simply depend on the horsepower that gateway has. So, you know, to kind of put things in perspective, there are a lot of, you know, $300 to $400 gateways out there that have LTE and Greengrass running. They're fantastic. If you're really asking that to bring in sensor data from, you know, dozens, if not hundreds of sensors, you might just need to scale up and upgrade that particular gateway. But there's no, as far as I'm aware of, there's no limitation to the Greengrass server itself. It is a hardware limitation, not a service limitation, if that makes sense.
Thank you.
Yeah, I think you put that perfectly.
Yep.
Great. Okay.
So I mentioned dashboard applications, so Jim can talk about some of the things that his team has done with kind of modernizing some things around dairy. So all yours, Jim.
Awesome. Thanks, Derek. Good job. This is a great example, I think, of some work specifically we're doing in the UI and UX area, which is just, I mean, that's a huge part of any of our IoT program and going forward. But what we took is this is the standard. This chart that you're showing here is a circular 7-day recording chart that in the United States, every dairy tank, every bulk tank that stores milk on a dairy farm has one of these charts tied to it. You can see they're a calibrated motor that spins, you know, based on a time clock with ink pens, and it's old school. They're highly complicated, but man, it is a great, valuable chart that we fell in love with, and it kind of became our passion to try to figure out how we could you know, provide the same data that's being provided, you know, in our next rounds. And the next slide will kind of show the development steps that we took, you know, from the horizontal graphing chart. We went to I call it the amoeba look, where we were trying to get the same data to plot correctly. And then to our last chart that we actually just released last week, or on the 1st of December. And then this shows our electronic 7-day recording chart that gives the customer, you know, all the same data. We can still validate it. You can still verify. You can still get in, but rather than having the paper copy that these guys, for several years, these farmers will have to maintain, you know, paper records for validation and verification. And although we still got some more hurdles to go to, we're hoping that this will finally be kind of the will help convince it to allow the technology to kind of change and adapt. And that's going to be our efforts that we're going to push hard on.
Jim, this is Brett. I mean, they've been looking at these farmers and looking at this paper chart for many cases, decades. Do you find that when they see that paper chart rendered electronically, it just makes sense to them, right? They're not having to learn they're not having to learn the interface. They're seeing a rendition, electronic rendition, and what they're used to seeing, and it just, the adoption curve is almost immediate. Is what you're finding as well? These farmers look at it and say, it makes perfect sense to me.
There's so much information, you know, available to them. Not just confirming the temperatures, which this is given, you know, picture proof. Every time a milk truck driver picks up a load of milk, he literally verifies that the temperature on the chart matches his calibrated thermometer. So it's you know, authenticated daily. It tells them they're getting the sanitation that's required. They can tell wash temperatures are reached, and they can also, you know, they can. For trending analysis, boy, overlaying these charts is invaluable. It's been great. And where we're most excited is showing this to the other markets and sharing this to our extraction group. We had a meeting yesterday with a big group, you know, on the East Coast, and they, you know, it was exciting just to see, you know, the value in it. And you know, we have to adjust it obviously for some of the lower temperatures, but it's been a fun process, and I just think it's a great way to really show all the data that's available and the ways we can use it.
Fantastic. Very cool.
And then this was kind of a quick little kind of before Brett and after Brett, but it was a kind of a, you know, just looking at how our problems have shifted, or not our problems, how our you know, our IoT path has kind of shifted our focus. When we were originally meeting, you know, it was just simply getting remote access to the equipment. If we could get alarm notification and have some visibility that alarm happened, that was, you know, that was icing on the cake. And, you know, confirming the system was running we had challenges collecting the right data at the right time, as the issues with Wi-Fi connections and the quality of the sensor data, which is the next point. I mean, those were ongoing battles that we had. And then really why we had the tool, our Pro Elliott tool, was to determine what happened, but the real value didn't come until after the failure occurred. And that's one of the biggest things that's great to see us being able to use the data to prevent those faults from ever occurring. And then if you look at after, we're making as often as we can, unless Ethernet or cellular or Wi-Fi is really the only option, we push them for the LTE and the cellular connection. And it's not necessarily more secure, but it just gives us the independent autonomous position that we like, and it works out well. Setup is easy. We can do easy product and equipment updates, and that's been a huge development. The pre-fault alerts, the trending alarms, this integration project that we're doing is it's exciting to see just the additional benefits that we're going to bring to this. And then today, already just taking, I call it the known ML and AI that we're able to do just with our common knowledge, and that's just simple flow adjustments, adjusting capacity control, and the fluid temperatures, based on this data that we're collecting and factoring that into those set point decisions. The next item is being able to, if you go back to the previous slide, we showed that transition, and really our UI UX, it's become where we were a vehicle to provide my text away in the past, and originally it was to download a CSV file so we could graph out and find out what's going on, to now having an interactive and a navigation focused UI UX experience for all of our consumers, and through the whole cold chain, and then across numerous markets. And then the next one, giving us the consumer to dealer to technician all the way to the factory, communication and visibility. And then my last point is we no longer have sensor and data reliability issues, but now we have, this was from a presentation yesterday, now we have sensor telemetry durability issues. But I think that will forever be with us, and that's going to forever be a hurdle that we'll continue to improve on. This is our, is there any comments on that from the panel?
No, I thought that was great.
Good. Okay. This is kind of a quick overview. These are vertical paths of kind of our current edge and kind of what we're focused on, and a little bit of what we're looking at to do future-wise. You can see the column to the left is our on-farm. What we're providing now is the milk tank temperature. We're providing temperatures as the milk is being cooled. And as I mentioned, we're able to verify the sanitary, the wash. We're using a cellular gateway or a Wi-Fi gateway with a sensor technology. Our next step is incorporating and adapting that to the transportation, even getting where the transportation and the on-farm machines talk. We were talking about some neat handshake where we automatically begin agitating the tank prior to the milk truck arriving, and just simple steps that we can save minutes. These aren't pit stops that these milk trucks make at these dairies, but they are making multiple dairies a day, and 10 minutes saving 10 minutes per stop is huge in the big picture, and that's the kind of details we're focused on. And then the post to consumer cold chain, we see opportunities there. That's a little bit out there, but it's just you never. Oftentimes it's funny how the overlap in scope and focus will open up, continue to push these verification processes. Some additional stuff that we talked about, again, it's all cold chain verifications. The last bullet there that we are kind of working on now, next steps, is getting into the glycol percentage. This is our fluid, internal fluid operations, but some real game-changing stuff. And we actually have a our first field tests are going in on that, and that should be standard product going forward. So in our industry, that's a pretty big next step that we're excited about incorporating into our toolbox.
Great.
Yeah, I think with each one of these, Greengrass plays an important role, particularly on transportation. With you're driving down the road, you may lose that connectivity. You may need to do a local action or a local alert. It's important for Greengrass at these various stages of the cold chain verification process.